University of Brasilia, here. Got his DEA from University Complutense of Madrid, Spain in 2007. Received his doctorate degree from UNB in 2008. Got his PhD from UCM in 2016. Hello. Good. He has more than 20 years experience in computer networks, information systems, and network security. His field of study includes information systems, computer networks, network security, and information security. His professional skills includes IT consulting for private organizations and the Brazilian federal government. His fields of interest and research include network management, network systems, wireless networks, open source software, network security, distributed systems, and information security. He is a member of the postgraduate program in electrical engineering, PGEE, and electrical engineering department at University of Brasilia, here. He contributes as a researcher and a professor at the Brazilian National Science and Technology Institute of Cybersecurity, INCT, Latitude Laboratory. He's a member of Aquarela Research Group at University of Brasilia, and he is also a member of GASS Research Group at University Complutense of Madrid. So, without further ado, I will give you Professor Robson.
Thank you, Professor Leonardo. Good morning, everybody. So, first of all, thank you for the invitation to talk a little bit about IoT security. And the idea that I'm going to present is basically this agenda. Let's discuss a little bit about IoT fundamentals, so the complexity of the IoT environments, some security aspects regarding IoT and why it's so complicated when we think about security involving the IoT environment. Present you some research results from our research team here at the University in Latitude Laboratory, and a little bit some information about challenges and perspectives about security and IoT security. So basically, what's IoT all about? We have the things, a bunch of devices, embedded systems, sensors, and a lot of different devices that are connected somehow. Of course, if they are connected somehow, they need to communicate. And using networks, protocols, and some sort of interactions so they can exchange information or can be together, connected together in some sort of organized environment. But when we consider the topic internet, it's because it's connected with the external environment and using the internet somehow. And of course, when it's connected with the internet, there's a context provided by the internet, and it's related some sort of services that these devices can provide to the users. When we review the literature, we see that's not one unique definition of IoT due to its complexity and due to the amount of information and the amount of technologies involved in IoT environments. So basically, the definition depends on the vision of who is proposing the entity or the environment with respect to the assets that it is used, and if it is more relevant in the perspective of who's the proponent of the environment. Basically, when we consider the, can you change the battery, please? When we consider the perspective of the IoT environment, it's important to see that it has so many different technologies and environment regarding the IoT itself that's very complicated to define it in one sentence. We have enabled technologies and systems architecture. For example, we have sensors, gateways, and microsystems involved in the creation of some sort of environment. We have different protocols. We have problems with energy management. We have the possibility of organizing sensory networks and so on. Of course, to create devices and to make embedded systems work, we need some software architecture behind it. So, for example, we have different operational systems. We have firmware implementations. We have middleware solutions to permit different systems to communicate. We have cloud solutions regarding IoT. We have application programming interfaces used to connect things together. And due to the architecture regarding IoT, we have some sort of data management problems and big data technologies and big data problems regarding IoT itself. We have services and applications. For example, one of the most commended application that is being studied about IoT is the use of the concept of smart cities. And of course, there's the concept of social IoT that's being used nowadays due to the amount of smart devices that are spread all around the world. We have management problems because the amount of information and the amount of devices connected so huge that they need to get more or less self-organized in a sort of network, which this is also a big challenge and a big problem regarding management in those systems. Some of the things that we will discuss here is more regarding security and a little bit of privacy, because IoT by itself uses and creates information from people, or basically personal data. So some questions about this is important because where is your data stored when you use some sort of IoT device? And due to the amount of devices, the amount of technologies involved, of course, there's business models and ecosystems regarding IoT. So we see the creation of new business models, we see value of chains being created, and some sort of applications domain regarding all this environment and all the technologies involved. And of course, we have social impacts, because IoT is changing the way people see things, the way people connect with each other, the way they manage their own homes, and so on. So IoT, it's a very complex environment, and all these things are related to it. So it's very difficult to create one definition for IoT, because we have considered a lot of different technologies and different aspects and contexts of use it. But in a sort of resume of what's IoT, we see basically three different layers. We have the devices that senses the environment and provide information, for example, temperature, for example, humidity, and so on. We have networking and data communication, so the information collected or provided by a different devices or sensor can be sent to a sort of collecting environment. And of course, we have the applications. But in the perspective of some sort of stakeholders, we have the whole environment regarding IoT. For example, we have IoT being used in healthcare environments, in social media solutions, regarding logistics, regarding mobility and transportation systems, and so on. So if we consider all this perspective and all the technology behind the use of IoT, again, it's a very complex environment, and we have a lot of challenges regarding information security and security itself in the perspective of researchers. Another perspective from ITU is that when we think about IoT, or Internet of Things, we have the perspective of anything connection, It means it doesn't matter which type of device that you are using, it's going to be connected somehow using some sort of protocol. It's going to be at any place with the perspective of the connection to and any time. So, in the perspective of anytime connection, it doesn't matter if you are stopped or on the move, if it's day or if it's night, if you are indoor or if you are outdoor. In the any place connection, the same. Doesn't matter if you're on the move, inside or outside buildings, using PC or smart devices. And the connection is between devices or personal computers or personal gadgets. We have human-to-human interaction, but not using directly a personal computer. You can be used in embedded systems or a wearable device. You connect to the thing as a perspective of human. If you are using sort of clothing with some sort of sensor, somehow you connect to the thing yourself. And the thing-to-thing perspective, devices connecting to devices. So if we consider the research fields that Internet of Things are all related about, we see the use of the Internet protocol, but not all the devices regarding on the perspective of implementation of IoT devices support the protocol, the Internet protocol stack. So new protocols were created, and a lot of security problems about these protocols will be discussed here in this presentation. We have the concept of Internet of People. We have creation, everyday creation of applications. We have the concept of the embedded devices with information regarding the implementation of firmwares or fault firmwares. We have communication technologies. So to create a definition of, one definition of the concept of Internet of Things, you have to purpose all this kind of information to fully understand it. So, regarding the security aspects of IoT, what we see is that IoT by itself, it's not secure in many different aspects. The problem is we have seen weak design of applications that are built without the security perspective. We have seen weak protocols being used in IoT environments. We have seen weak firmware design and implementation in all sorts of devices. Regarding firmware, for example, we see the use of different botnets exploiting vulnerabilities in the design of firmwares. But in the perspective of the devices itself, of course, there are limitations of the processing capabilities of these devices. But there is a shift of the perspective when we use the word smart, because that means that some sort of processing power, your smartphone, your tablet, your smart TV, and so on. So the use smart here creates a shift in the perspective of this device because there's some sort of processing power there. So basically, this is one of the stacks of the protocols that are used in IoT environment. We have the different layers here, link layer, physical layer, link layer, routing layer, or network layer, transport layer, and application layer. And some of the protocols implementation purposes the layers itself. So we provided a sort of review in some of these protocols regarding the aspects of the possible attacks regarding some of them. I'll show you some of them, some of the attacks now that are possible regarding depending on the implementation and depending on the protocol used. So IEEE 802.11, all these kind of attacks in the perspective of someone that is trying to disrupt the environment are possible. You can perform man-in-the-middle attacks, you can make eavesdropping, you can provide key cracking, and so on. which by itself it's very dangerous. Another protocol that's been widely used in IoT environment is the Bluetooth. So again, all these kind of attacks, it's possible considered in some Bluetooth implementations. And one curiosity about Bluetooth, in the past 2 or 3 months, sorry, there was a fault implementation of the firmware regarding Bluetooth stacks, and it affected basically all smartphones with Android operational systems. The amount of devices that were subjected to this kind of attack was in the amount of millions of devices, which is very complicated because exploring just the option that your smart device uses the protocol means that it's vulnerable to some sort of attack or a remote attack. So about the low-rate wireless personal area network standard, it's possible to provide eavesdropping, man-in-the-middle attacks, jamming, and other kind of denial of services attacks. For the RFID and NFC implementations, it's possible to eavesdrop, to provide replay attacks, to provide man-in-the-middle attacks, and so on. Basically, what we have seen is that there is not one protocol in the IoT environment that is resistant to attacks. All of the protocols we studied, provided in this review, could be exploited somehow in some kind of attacks, since the physical layer to the application layer. Another protocol that's been widely used in IoT environment, it's the 6LoWP panel, so IPv6 over low power wireless personal area networks. And the attacks that we can do in this protocol, we can spoof it. We have problems about fragmentation, because fragmentation, it's also a problem regarding some sort of IPv6 implementation. We can do replay attacks, we can eavesdrop the communication, we can provide man-in-the-middle attacks, and so on. Another protocol in the network layer is routing over low power and loss networks. We can provide sinkhole attacks, black hole attacks. We can provide selective forwarding. It's decide which frame or which packet we decide to go forward in the network. Another protocol that's widely used in IoT is the Zigbee. It's low-call, low-power wireless for machine-to-machine networks. And regarding this protocol, we can provide sinkhole attacks, black hole attacks, selective forward attacks, Sybil attacks, eavesdropping attacks, and many others. This list is not restricted. There are many more other attacks that's possible regarding this protocol. When we move one layer from the transport to the network layer to the transport layer, we have the implementation of the TLS, which is supposed to be a UDP datagram providing security. It's some sort of TLS implementation over UDP. Again, a lot of different attacks it's possible regarding the implementation to IoT devices. And in this case here, some of the names and the implementation of the attacks that are widely available over the internet. I can provide information about this one, which I used in experiments. This kind of attack gets in the middle of an SSL communication, and it's capable of eavesdrop the encrypted communication. Another protocol in the application layer is the constrained application protocol, and again we have some sort of attacks that can be applied to this kind of technology or this kind of protocol. We can provide amplification attacks, we can provide masquerading, and some of the results that we'll discuss a little bit is regarding amplification that I'll show in a few moments. Another protocol that's used in IoT is the MQTT, or Message Queue Telemetry Transport Protocol. That's also a protocol designed to machine-to-machine communication. And we can provide different kinds of attacks in this protocol too. So basically, what we see in the use of the IoT implementations and the IoT protocols is that we did not found not one only protocol that was resistant to some sort of attacks. And what we see is due to the flaws regarding, for example, firmware, bad firmware implementations or bad firmware designs are permitting the use of botnets regarding IoT. I can provide you information of two of the most biggest botnets that's already being used now. One is called Mirai. We'll discuss a little bit about it. And the other one is called Reaper. The difference between Mirai and Reaper is that Mirai tries to exploit flaws that are hard-coded inside the firmware. For example, the username and the passwords are hard-coded in the firmware. So you can provide a brute force attack and try to log in some sort of IoT device and get root or admin inside that device. So you can provide or control this device the way that you wish. And the other botnet is Reaper, which exploits vulnerable devices and using exploits techniques inside the firmware. Or this means that it's a little bit more complicated in terms of implementation for the botnet, but the perspective of the Mirai, it's about thousands of devices, and the Heaver botnet, it's in the source of millions of devices that can be exploited. And somehow we cannot provide that IoT devices do not join botnets because the implementations are weak. So some research results that we have here in our laboratory regarding, for example, the activity of the IoT botnet, which is Mirai. In 2006, we created a sort of honeynet environment, a sort of huge sensor to collect information about attacks over the internet. And in a few weeks of use of this sensor, we started collecting information about some sort of attacks, because in 2016 there was not much information available of Mirai. Now there's a lot of information, but what we saw at that time is that already 22 different countries were already infected with the Mirai implementation of botnets. And some of the countries that were attacking using the Mirai in our environment was, for example, Taiwan, China, United States. And here we have the implementation, the distribution of most of the countries, the services tried, and sort of a geo-reference information so we can see what was going on. So we decided to provide more research inside the Mirai, and in 2017, we provided some sort of deep packet inspection or DPI analysis, and we could see the users and the passwords inside the packets that Mirai botnet was exploiting. So all this kind of information here regarding the usernames and the passwords were hard-coded inside some sort of firmware implementations in those devices, which is by itself a bad practice design when we consider the use of, for example, ADCL routers or DVR routers or IP cameras. So the activity regarding Mirai is possible because all this information is hard-coded inside of the firmware. Another perspective that we saw in Mirai is the modus operandi of the botnet itself. For example, when one device is compromised, basically the control of the Mirai tries to provide the shell information or admin information or enable information. For those who are aware of how the client line interfaces of some sort of devices works, for example, in some sort of Cisco devices or TP-Link devices, when you provide through the CLI command, the enable command, it means that you're going to become the root of the devices. And if you become root, of course, you can do anything with the device. You can include it to start attacking people. And as information, this botnet was responsible for the attack that took half of the United States attack using the DNS. So they used Mirai to provide recursive implementations of DNS, which led to half of the connections regarding DNS in the United States to become non-responsive. And you can see of course, there's too much damage that this sort of attacks can provide to the victims. Another research that we did was using the implementation of the Simple Network Management Protocol in the perspective of the IoT devices, because some of the smart devices are responsive to SNP for management purposes. So what we could find is that depending on the implementation that we can achieve, we could amplify an attack in about 600 times. What that means? For every byte that we use, or that an attacker is able to provide, a victim will receive 600 more bytes. So it's a sort of amplification, distributed denial of service attacks. And more information about this, we published this in this paper here, which free is open source, open access, available for all. Another research that we did in our lab showed that IoT is also a big data problem, because the amount of information generated is so huge that in a few days, in a few months, we are dealing with terabytes of information. We provided a simulation, consider just one producer in a big data architecture, simulating 33,600 homes, and each home with 4 IoT device, for example, a sensor that provides temperature, a sensor that is supposed to open or close the window, and so on. What we see that is in a month of simulation, 4 devices in this amount of smart homes provided 2.86 terabytes of information, which, considering the small devices, is a lot of information generated. So IoT is also a big data problem. Well, for the discussion, the basic discussion, some challenges and perspectives about IoT. In the security perspective, what we see is that we have flaws, security flaws in all levels of IoT implementation. So by itself, IoT is not secure, as I said before. We also have to consider, because there is a trade-off between usability versus security. Most of the devices used in IoT are not supposed to implement security by itself. But once that this implementation do not consider security, these devices can be used to be exploitable and provide some sort of information to attacker, or can be used against all different kinds of victims over the internet, because once they are connected to the internet, attacks can come from all over the places. Considering the IoT, the design of devices regarding IoT, sensors and applications that are used in the SCADA and ICS systems should be reviewed, because most of the systems and the sensors that are widely used and widely developed nowadays are applied to critical infrastructure solutions, and they are not secured by itself. So it's a problem because you can start providing wrong information for the management systems, which leads to bad decisions. What we see too is that IoT vendors do not consider the use of security teams to try to provide more security to the systems or to the devices being created. Of course, there's a trade-off between cost and benefit that should be considered. Regarding privacy, basically, where is your data stored and who accesses it? Because once IoT devices deals with personal data, it can provide information about where you are, about your health state, and so on. And most of the implementations do not consider cryptography during the transmission of the data, so they're possible to be eavesdropped and provide information for attackers to use against people or against you. Of course, as we said before, it's a big data problem because there are small devices regarding IoT, but these small devices provide huge amount of information that's being generated. But this information cannot be stored in the device itself. It has to be transferred over the network and be stored in sort of centralized environment. And to process and analyze, it takes a huge effort. So the use of cloud solutions, so it's also another perspective. But regarding cloud by itself, in my opinion, the problem is just going to be amplified because cloud by itself is not secure, true. So there are needs of regulation, so government should get involved when regulation is important in the use of IoT. In my opinion, industry by itself will not solve the IoT problem. It's necessary to provide IoT policies and to regulate the IoT markets. And in the perspective of research and development, we see plenty of opportunities here. There's a lot of space to provide research and to provide more development. So thank you. And here is my email if you can get in touch with me. Thank you, Professor.
Thank you, Professor Robson, for the very interesting lecture. I would ask for the audience if there are any questions. Please, Professor Divanilson. I can, but if somebody can't.
Last month, a very, very famous attack on WPA2 Wi-Fi protected networks has been shown. The crack, that stands for key resolution attack. So I'd like you to shed some comments, some light about the potential of this attack on user devices, IoT devices. And a second very quick question is if you could comment about countermeasures to machine learning techniques that are used to detect, for example, user vulnerabilities and privacy issues in smart devices.
All right. For the first question, is about the crack attack. The crack attack, it's a flaw regarding the implementation of the protocol, the WPA2 protocol. And from the review that I did inside of this attack, basically all devices which use the old implementation of the WPA2 are vulnerable to this kind of attack. This attack permits you eavesdrop the communication and break the cryptography regarding. So every device or IoT device or smartphone device or smart TV device that use the WPA2 implementation is susceptible to be exploited. It's vulnerable to that. To fix this problem is not just the use of or update the firmware on the systems, because for example, we are here in a conference that we are using a Wi-Fi network. Is that Wi-Fi hotspot updated? We do not know. So the people who manage the environment is responsible for providing that kind of information. But what I saw, it's all Mac solutions, most of the Android implementations, most of Linux implementation, all of them were vulnerable to this kind of attack. And the other question is about machine learning and the predictive. Well, there's a sort of research field that's called now behavior analytics, and it uses information from the environment so it can learn from the environment if some sort of behavior is normal or abnormal. The problem with that, it depends on the environment. How can you say if the environment is normal by itself, because it can be already compromised? So you can provide wrong information for the machine learning algorithm, so it will start giving you wrong information about what's normal in the environment. In this kind of research, we have seen IBM and Google providing some sort of machine learning algorithms, for example, the Watson subsystems, and Google with DeepMind implementation of the algorithms. I see that it's a possibility to provide more information to protect the environment, but it depends on how the algorithms works and the amount of information that's used to train those machines. So again, there's a trade-off between security and usability. Right?
Thank you, Professor Robson. Okay, let's continue.